In this video we're going to have a look at how we can use the trigonometric ratios to work out the missing angle in a right angle triangle. The steps to this are very similar to the ones that we've used when we were trying to find the length of a missing side. We're going to go through a very similar series of steps. Let's have a look at the example here. So we've got a right angle triangle, we know that, we've got the right angle in the corner. We've been given the length of the hypotenuse is 6 centimetres and we've been given the height of the triangle is 4 centimetres, and we're trying to work out the angle in the bottom left hand corner, this angle x. First step I'm going to do is I'm going to label up the sides of my triangle. So the side that's opposite the right angle, the longest side my hypotenuse, the angle that's opposite the angle that I'm trying to work out is value x, is going to be my opposite side of 4, and the side that's left is my adjacent side. I'm then going to work out which one of my three ratios I'm interested in using. So I'm interested in the opposite side, I've been given that value. I'm interested in the hypotenuse, I've been given the value of 6. I haven't been given the length of the adjacent side, so it's no use to me. So the two ratios that have got the adjacent side in, I can eliminate. So the cosine ratio has adjacent over hypotenuse, no use. The tan ratio, opposite over adjacent, again, no use to me because it needs the adjacent value and I don't know what it is. So the ratio I've got left, sine A is equal to opposite over hypotenuse. I'm going to write that down. So sine A equals O over H. I know the opposite value, it's 4, I know the hypotenuse, it's 6. In this case we're looking for the value x, don't know what it is yet, so sine x is equal to the opposite value, which is 4, divided by the hypotenuse, which is 6. So sine x is equal to 4 over 6, I can simplify that down, that's 2/3, 0.666. This is just the value. So we've worked out that sine x is equal to 0.6, a decimal value in here. We still don't know what x is. If we've got another equation, we've done something like x squared and we're trying to work out what x is, we need to do the inverse operation, the opposite operation. In that case, opposite from squaring would be square rooting. If we were adding 4 and we wanted to find out our value, we'd do the opposite operation. So instead of adding 4, we'd subtract 4 from both sides. It's exactly the same with our trigonometric ratios. We know that the sine of the angle x is equal to 2/3. We want to do the inverse operation of sine, and that's going to be written as x is equal to sine with this minus 1, sine to the power minus 1. We call it the inverse sine of the value we've been given, which is 2/3. Sine to minus 1 of 2/3. Haven't got a clue how I could do that in my head. Not got a chance. Fortunately, the calculator can do it for us. So what we've got our three ratios. We've got our sine, our cosine and our tangent, and just above them, in my case on this calculator in blue, I've got sine with that little minus 1 to the power above it, so sine to the minus 1, I've got cos to the minus 1, and I've got tan to the minus 1 over here. So the one I want to use is this sine to the minus 1. So switch my calculator on, just clear it. I need my shift button, hit the sine, so this has given me sine, make sure we can see that on the screen, sine to the minus 1 of the value. Well, in this case we're evaluating 2/3. So sine to the minus 1 of 2 divided by 3, close my brackets off, is equal to 41.8 degrees. So x is equal to 41.8 degrees to 1 decimal place. Okay, so what steps did we do? We labelled our sides up, hypotenuse first, opposite the right angle, opposite one, opposite the angle we're trying to calculate, adjacent side. We worked out which ratio we wanted to use, in this case it was sine. Substituted our values, so sine x is equal to 4 over 6, which is the same as 2/3. And then we've taken this inverse sine. Sine of x is equal to 2/3. I need to do the inverse sine. So x is equal to sine to the minus 1 of 2/3. We've used our calculator and it's given us a value of 41.8 to 1 decimal place. Let's have a look at another example. We've got another right angle triangle. I'm going to go through the same steps as before. So first step, I'm going to label up my sides. So opposite my right angle is my hypotenuse. Opposite my angle that I'm trying to find, my angle X, is going to be my O. And the side that's left is my adjacent side, which I am going to call A. So in this case, we've been given the hypotenuse and the adjacent. We've not been given the length of the opposite side. So if the ratio has got the opposite in it, I don't know that value and I can't use it. So sine has got opposite in, no use. Tangent's also got opposite in. Don't know what the opposite length is, so I can't use that ratio. I'm going to be using the cosine. So the cos of A is equal to A over H. I've written my ratio down. I've already identified the correct ratio. If I'm lucky, I've got myself a method mark. I'm going to substitute my values. Cos of the angle we're trying to find, X in this case, it's equal to the adjacent side, which is 9. And I'm divided by my hypotenuse, which is 14. 9 divided by 14. This is a value. My calculator could work it out as a decimal. I've got cos of X is equal to 9 over 14. So I know what the cosine is. I need to use the inverse cos function. So this is going to tell me that my angle X is equal to the inverse cos, so cos to the minus 1 of my value of 9 over 14. Need my calculator again. So we're going to do the shift button with the cos function, so it gives me cos to the minus 1. I'm going to put my 9 over 14 in. 9 divided by 14, close my brackets, press it equals, and I've got a value 49.99, so I'm going to round that up to X is equal to 50.0 degrees to 1 decimal place. Okay, let's have a look at a third and final example. Another right angle triangle. Still trying to find a missing angle X. This time we've been given the base, which is 8 centimeters, and the height is 6 centimeters. I'm going to label up my triangle. So opposite my right angle is my hypotenuse. Opposite the angle I'm trying to calculate, opposite side, and the side that's left next to the angle I'm trying to calculate, my adjacent side is 8 centimeters. So we've been given O, we've been given A, we don't know how long the hypotenuse is. So if my ratio has got hypotenuse in, I need to eliminate it because I don't know what that value is. So I can't use sine, it's got hypotenuse in, I can't use the cosine, it's got the hypotenuse, must be using my tangent function. So let's write the formula down. Tan of A is equal to O over A. I'm going to substitute my values. My opposite side is equal to 6. My adjacent side is equal to 8. And this is my tan of my angle X. 6 over 8, I could simplify that down, so it's equal to 3/4. Doesn't actually matter because you can put 6/8 into your calculator, you're going to get the same value, but sometimes it's helpful just to do that simplification. So the tan of X is equal to 3/4, 0.75. I want to do the inverse operation, so that's going to be using my tan to the minus 1 of 3/4, or I could use my decimal 0.75. Back to my calculator. So my shift button with the tan function is going to give me tan to the minus 1 of the value that I'm trying to calculate, 3/4. 3 divided by 4, that is equal to 36.869. If I round that to 1 decimal place, that's going to give me 36.9. So X is equal to 36.9 degrees, and we finish the question off.